Order of operations. Have you ever heard of bed mass before? Yes. In grade 6 you learned it? Did anybody learn it as ped mass? Yes? Yeah, it depends if they just call them parentheses or brackets. You got ped mass and, yeah, okay, we can get into arguments. And technically, some of these don't matter the order, because you could switch adding and subtracting. You could switch dividing and multiplying. So you could have bemza, but it just doesn't ring, right? You can, or if we bed masa, bemdas, bemda, yeah. So, and then exponents we could probably switch with the word powers, so that's so there's I think they went with bed mass because it was easy to say and then easy to remember. And it tells us a way that we have to do our mathematics. And these are arbitrary rules that were made just so that people didn't come up with different answers. Because you don't want, if you're trying to explain something to somebody else, you don't want them doing mathematics differently. And some of those things are not big deals, but sometimes they can be a big deal if you're like, oh, we'd like to shoot a rocket ship up into space, but we need someone to do some work on it in Japan. So we send it over there and they say, do this math. And they're like, oh, we do our math differently. And they send the ship back and you send it off into space and boom. That wasn't a good idea. It blows up.
We don't want to be doing SAMDAB when it's
SAMDAB. Okay. So order of operations and how to show our work as we're doing them. And I gave you a little bit more space than I gave myself, which is a good thing. So what you would do is you would look, think about bed mass. I'm going to write it up here just so we have it in our heads. Do we have any brackets in this first one? Yes. Okay. What's in the brackets? Only one thing to do, so we could do that one thing. What is 4 minus 5? It would be minus 1. So if we were showing our work, I could put a minus 1 under this, and then I would have plus 2 squared. And sometimes you're going to find, you're going to learn you can do things a little bit faster than this, but, right, because some of you might have went, oh, I'll do the minus 1, and then at the same time, can I do the exponent? Yes. So I am going to create some space for myself and then bring this back afterwards. Now, when we're doing mathematics in more than one step, I'm going to tell you that I like to work vertically. And this is going to set you up for your mathematics in higher levels as well. What did I do next? I did the exponent, right? And notice how I wrote the 4 right underneath where the 2 squared was. Remember what an exponent means? 2 times 2. 2 squared means 2 times 2, so that's 4. And now we've got adding. What's negative 1 plus 4? Positive 3. Okay? Now, if you're having trouble adding with integers, and that can sometimes be something that's confusing, when I get to this negative 1 plus 4, I find that if I think of my number line, negative 1 plus 4 means you're starting at negative 1, and adding 4 means that you're going to go 4 to the right. Adding is going to the right, subtracting is going to the left. Because you will make mistakes when adding and subtracting integers, just because it's hard on your brain And it's a little bit confusing once you add those negative numbers. But if you go back, if you're ever like, oh, I'm getting screwed up on this one, go back to a number line. If I was at -1 and I went 1, 2, 3, 4 to the right, it's pretty easy to see that you would get to 3. Okay. First example, done. Everybody got it written down? Because I erased the next examples to see so that I could work vertically. I was a little bit mad at myself at my own notes. I think I gave you enough space to work vertically. Okay. Here we go. Erase the first one. Add space for my second one. I made a whiteout pen. There's so many fun things you can do on a smartboard. I'll teach you how to play mini golf sometime. Okay. Second one. Do we have brackets? Well, yes, we have brackets, but in this case, is there anything to do inside the brackets? No. Sometimes we have brackets just to hold a number. Usually holding numbers in brackets is because they're a negative number. So in this case, I have brackets, but that's just holding a -4. I don't know, maybe they're afraid the negative's going to run off somewhere. They're like, oh, we got to keep it in brackets, keep it contained. Not sure. Then do we have any exponents? No. Do we have any dividing? No. First thing we have is multiplying. You see it multiplying in 2 places. So you could do the 5 times 2. Oh. Do you know all the ways that have you seen a dot for multiplying before? Yeah. Okay. Some people, yes. So in mathematics, when they teach you multiplying very early, what symbol did they put between? Like an X. Okay? And then as you get into high school in grade 9, we're going to be doing a fair bit of introductory algebra stuff. And we use X in algebra as a variable. And so now it's sort of like, ooh, is it confusing if we've used X for multiplying and X for variables? Yes. So then they start to say, well, let's say, what else could we do for multiplying? And they're like, let's use a dot. Well, they don't usually use a dot as a variable because they're using a letter. And last time I checked, A, B, C, D. No, there's no dot in the alphabet. Okay? Does anybody know another way that they've shown multiplying? Right beside each other. Like this in brackets. Why do they need brackets when they're right beside each other? So that you don't get confused with 52. Because if I wrote 52, you'd think 52, you wouldn't think 5 times 2. Okay? But there will be some times where we can put things right beside each other that means multiplying without brackets, and that's when we get into algebra, like 5a. This would be 5 times a. And they're just right beside each other. So there's a bunch of different ways to show multiplying. And it's, if they would have just went with the dot to begin with in elementary school, maybe it would have solved a whole bunch of problems. I don't know. Okay. So, in this one, 5 times 2. Did you get 10? Plus -4 times 7, -28. And so here would be a place I'd just hold that in the brackets because you have an extra negative with the number. Do you remember what adding a negative is? It's same as subtracting. So adding a negative, I can just change this to 10. Oh, I didn't want to do that. 10 minus 28. If you think of your number line, you start at 10. It's 10 degrees out. You go down 28 degrees. What temperature would it be? -18. A very fun thing to do is to leave Winnipeg when it's -40 and fly to Mexico where it's plus 30, and that's a 70-degree change. A not very fun thing that you have to do after you do that is fly from Mexico back to Winnipeg. And it starts at minus 30. And you go back to minus 40, and it's a 70-degree change in the other direction. In the wrong direction. Okay. Everybody good on this one? Again, see how we showed each step underneath? This can be really helpful for you seeing what you did well and what you did wrong. And sometimes you're going to get questions in your homework, in your textbook. I'm actually going to give you an assignment, and you'll want to be showing your work like this as you go. Okay, I'm going to erase this. Everybody okay? Erase this one. We're on number, oh, you know what I almost said? We're on number C. You like the number C? Ooh, here's a little puzzle. What's the first letter of the alphabet that's also a number? No, A is not a number. B is not a number.
What was your question?
What is the first letter? What is the first letter of the alphabet that's also a number? It's even on your calculator. E. E is a number. You find it on your calculator, you can push it, you'll find out that E is equal to 2.718281828. Oh, but that isn't a number. There's the number E right under push enter. Yes. You'll have it on there somewhere. Sometimes it shows up as e to the x. Second. Anyways. Oh, I'll give you another speed of light. But it's not. It's okay. Maybe I could give you that. All right, here we go. Ooh, we got multiple brackets on this one. 24 divided by bracket 3 plus bracket 7 minus 2. What do you do when you have brackets inside of brackets? Well, you would do the very first thing we would do in this one is the 7 minus 2. What is 7 minus 2? 5. And once you do the calculation in the brackets, if the number is positive, you can get rid of the brackets. Now what can we do? We have brackets again. 3 plus 5 is 8, and now we have 24 divided by 8, which is 3. And so sometimes you can put equal signs as you go along. We get 3 as an answer. Okay. Oh, I forgot to ask you if you were done. Well, too bad, so sad. Oh, and I erased the wrong one. We're on E now. We haven't done E yet. Okay. We're on D? Oh, they look the same. That's why I thought we had done it already. Oh, but there's less brackets. Sneaky. Okay, 24. We have brackets. Divide by 3, so this goes plus 5. What's the difference in this one? We do the 24 divided by 3 first. 24 divided by 3 is? An 8 plus 5. Do you like bad math jokes? No? Yes? Yes? What did the 0 say to the 8? No. Nice belt. Okay? Okay. If you put a belt around a 0 and tied it untight, it would make an 8. It's a bad joke. Yeah, it's bad. Yeah. Oh, I have some bad math jokes. Some of them I don't even know if they're too bad. Can't go through them. No, one at a little bit at a time. Okay, everybody got this one? 13? Now we're on E. Okay. In E, do we have brackets? Yes. Is there anything to do in the brackets? No. They're just holding numbers. Okay? The dividing and multiplying, do we have dividing and multiplying? Yes. 54 divided by 9 is 6. And here we have multiplying. 4 times a negative 5 times a negative 3. Well, 4 times negative 5 is negative 20. And negative 20 times negative 3 is positive 60. And then 60 plus 6. 6 plus 60? 66. There we go. Are we ready? Question? No? Good? All right, we're on F. Do we have brackets? We do have brackets, but they're just holding numbers. So nothing to do, no operations to do inside. Okay? Do we have exponents? No, but we have dividing and we have multiplying. What's there beside this one? Okay. Ooh, dividing by decimals. Negative 1.2 divided by 0.3. What's the answer to that mental math? Okay. Well, sometimes when you're thinking about dividing, right? If I do something like 8 divided by 2, you just know the answer is 4. But the reason the answer is 4 is if you had the number 8 and you broke it up into 2s, how many piles of 2 or how many 2s would it take to add up till you got to 8? 2 plus 2 plus 2 plus 2. You need 4 2s to add up to 8. How many 0.3s would you have to add up together before you got 1.2? 4 of them. You just did mental math with decimals. And since it's 1.2 divided by a negative 0.3, it'll be negative 4, and we still have the times 1.5. Now, multiplying 4 1.5s, that would be 1.5 plus 1.5 plus 1.5 plus 1.5. What does that add up to? Close. 1.5 plus 1.5, 2 of them would make 3, right? And so 4 of them would make 6. And because it is a negative times a positive, we would have negative 6. And now think of your number line. You are at, here's 0, here's 1. You are at negative 0.8, and you need to go 6 in that direction because you're subtracting 6. Where would you end up? Negative 6.8. Now, if you have a calculator, what I want you to do right now is take out your calculator, and depending on your calculator, the nicest calculators for grade 9, you can see what you're typing. So for example, on my calculator here, I can put a bracket, just like I have there. Then, here, I'll move it over here so I can actually see. Then I can write negative 0.8 bracket. That's exactly what I have. Then I have a plus sign, plus. And then I have 1.2 divided by, then a bracket, negative 0.3 bracket times 1.5. If your calculator shows you what you're typing, that is a good thing, okay? If your calculator that you have doesn't show you what you're typing, you might say, hey, Mom and Dad, could you get me a calculator that shows me what I'm typing? Because if we push enter here, we can see it all at once what the answer should be, negative 6.8. And we can feel like, oh, yeah. This is always a scary part for me as a teacher, because we just did the math, right? And now I'm like, and then your calculator can tell you if you're right. And I get this little scary moment right before I push the enter button. Because if I did it wrong, and I push enter and it gives me a different number, I'm like, so I just taught you guys wrong for a bit. I would figure this out. So, we got it right. So one of the things with the assignment that I'm going to be giving you with order of operations, you might want a calculator to be able to check. Can you type it into your calculator correctly to get the right answer? And if you have a calculator that gives a display, they're the best calculators because you can write it exactly as you see it. If you're using your cell phone as a calculator, that's a great calculator on your cell phone, but you're not allowed to use that on quizzes and tests. So you'll want to make sure you get used to whichever calculator you're going to be using on quizzes and tests to see if you can get it right. Okay, and for the next one, we're just going to do the next one on our calculator all at once. So for part G, I just want you to type this into your calculator and push enter and see if you get the answer. I will type it in here as well. Okay. Bracket 3.2 bracket minus 0.9 divided by bracket 0.7 minus, and some calculators, my calculator has a different subtract sign and a different negative sign. Bracket, bracket, squared. Oops, squared. There we go. So I double checked that I wrote everything exactly the same. Bracket 0.7 minus bracket, bracket squared. Push enter. Did you get 2.950692521? Then you know that your calculator is working for you. You got that in your head? That's impressive. That's really good. And one more. Oops. Here we go. We're on the last one, H, with fractions. Oh my goodness. Do we have brackets? Yes. Do we have something we have to do in the brackets? Yes. Okay, so I'm going to rewrite negative 1/2, negative 1/2, subtract negative 2/3, divided by, and in my brackets, how do I add fractions? I need a common denominator. So, and this is going to be something we're going to review. The common denominator between 3 and 12 would be 12, so I'm going to multiply both of those by 4. So 1/3 is the same as 4/12. And 4/12 plus negative 3/12 will give me 1/12. Okay? Next, in our order of operations, the brackets are now just holding numbers. No exponents, so now we're into the bed mass, we're into the dividing and multiplying. How do you multiply fractions? You multiply the tops. -1 times -1 would be +1. And you multiply the bottoms. 2 times 2 would be 4. Subtract. How do you divide fractions? You multiply by the reciprocal. So change the divide sign. Flip the second fraction. There's a review of dividing. And now I can multiply 1/4. -2 times 12 is -24. And 3 times 1 is 3. Okay?
After this, will you show a different way of getting rid of the denominators?
Well, we can't get rid of the denominators because we're working, it's not an equation. So we could, if it was an equation, we could get rid of the denominators when we're solving. But in this one, we have to keep our denominators because we're just adding and subtracting as we go. Now, I can go up a little bit, yep. Sometimes when you're adding and subtracting, you look if you can simplify. What is -24 divided by 3? 8. So this is -1, this is 1/4. Do you agree that subtracting a negative is the same as adding? And you get 1/4 plus 8, which if you wrote it as a mixed fraction, is 8 1/4. If you write it as a decimal, it's 8.25. Is that what it came up on the calculator? Yes. Okay. Order of operations, mini assignment, mini worksheet. So this one you are handing in. It is due tomorrow. Take one and pass it back, Jackson. There's not enough room, you can do it on a separate piece of paper, or you can write smaller. There is a bunch of questions here to practice, 40 of them in total to be handed in for tomorrow. 2 times 12. But dividing, you multiply by the flip.
I wrote it on the second line as 1/2.
Oh, okay.
And so then when I flipped it, I did
2/1, yeah.